Now, I'm going to give you a little bit more background to keep you reminded on the Bayes theorem you have learned before. Okay? So what is Bayes theorem? I'm going to give you an example. The example is, suppose there is a rare cancer disease. Rare, okay? Very rare. How do you quantify it is rare? That is the probability of a randomly selected person. Okay? To get this cancer, it's about, that means only 1 out of 10,000 could have the cancer, could have this rare cancer. Now suppose there is a blood test, a lab blood test, okay, in the lab that is 98% accurate, in the sense that 98 of those who have the cancer will be tested positive. Okay, 98 have to be, this guy has to have cancer, then I have the 98% accuracy. But the cancer to happen in the general population is 1 out of 10,000. Okay? But the lab blood test also shows positive for 2% of those who don't have such a cancer disease. Now the question is, if a randomly selected person takes a lab test and the result is positive, what's the probability that he really has this cancer? 98? No, 98 is only for those who have cancer. Okay? It's not 98. Is it 98? 98 is for those who have cancer. You can test positive, right? That is a 98% accurate. 98 of those who have cancer will be tested positive. But that 2% of those who don't have cancer also test positive. Okay. So if a randomly selected person takes a lab blood test, what the result is positive, what's the probability he really has this cancer? Okay, this problem is actually, let me save this one first. You can find this problem in my website. I'm going to show you my website. Okay, hopefully you can see this very clearly. So is the font size big enough for those in the back? Mon, can you see it? Bigger, okay. Is it okay now? It's a little bit hard. Let's see what's going on here. So this is called a confusion matrix. For those who are going to do the healthcare, this may be useful. True positive is diseased people correctly test positive. Okay. False positive, healthy people wrongly tested positive. True negative, healthy people correctly as negative. False negative, diseased people wrongly tested as negative. Okay. We have 2% to test the general population, okay, who doesn't have disease, and who will be tested positive. 2% of those who does not have cancer but test positive. So that's false positive. And 98% accurate in the sense that 98 of those who has a cancer, diseased people, test positive. This is 98 true positive. Okay? Okay, now if we randomly select a person, take a blood test, the result is positive, what's the probability he really has the cancer? Before we do that, first let's make sure we're very clear about the true positive. True positive is given disease is positive, 98%. And the false positive is healthy guy positive, This is false positive. This is type 1 error. Type 2 error is disease guy negative. You didn't detect it. Okay? So this is called type 2 error, false negative. You see these two types of error are different. Okay? They're not the same. What is true negative? True negative is healthy people, and you tell them you are healthy. Okay, that's correct. Okay, so that's true negative. This is true positive. And this is a test results. Disease, you test positive. No disease, you test positive. This is actual condition. And this is disease, you test negative. This is no disease, you test negative. Make sense? So we have all these categories, at least 4 categories. You can fall into one of those categories. Now in our problem setting, so the false positive rate and the false negative rate are not necessarily the same. But in this case, we set it, both of them are the same, 0.02 for this example. Okay. So if the person has disease, positive is 0.98. Okay. If the disease is a negative, that is a complement. Okay. Right? If the person has disease, the negative is 2%. If the disease positive is 98%. Now we want to know if test positive, what's the probability to have disease? So this is what we were given. We were given that if this guy has disease, if he has disease, what's the probability that test is positive? This is given, but we want to know if the test is positive. We actually don't know whether this patient is diseased or not. Just some randomly person come to the lab, I test, it's positive. Then what's the probability to have the disease? Okay, so this conditional probability and positive to have the disease, given positive, what's the probability to have disease? Equals to positive given disease multiplied by probability to have the disease, and then divided by probability positive. Agree? This formula is okay, right? Because positive is in the denominator, so that's given, right? So this is the definition of the conditional probability. So what's this probability? We were given, right? 98%. If diseased, positive. Then what's the probability of having disease? 1 out of 10,000. So this is this number, right? Now what is the probability of positive? Probability of positive is given the guy's the disease, what is positive? No disease, what is positive? So it's 0.001 times 0.98 and 0.002 and times 0.9999. Okay. So what is the probability given the test is positive and the person have disease? It's actually what's the probability? If the test is positive, what is the probability this person has disease? 0.48%. I'm actually just use an extreme example to show you. Even if you false given disease positive, the lab test is very accurate, actually, 98% for those who have cancer. But why is this probability still so small? That is because of the disease is so rare. Okay, that is because of this number is so rare. Okay, so knowing that you tested positive increase the probability of having the disease from 0.01 to because 0.01 is a randomly select person have the disease. And now if it's passed positive, it's actually only increase the probability to 0.00487. But not all the way to 98%. Okay. But this could change because previously we are saying, oh, it's a rare disease. Now, if the 60% of the original population have the disease, not one out of 10,000 anymore. If the 60%, that means it's pretty like it's like a pandemic, right? In the population. Now the prevalence of the disease is 60%. Now let's see what is the result again. So positive. Only change here is 0.6, so 0.6, 0.4. So now, if positive, then the disease rate is actually 98.65%. Do you guys see the difference? For a rare disease, or the disease is not that rare, it's prevalent. So hopefully through this example, I show you the importance of the false positive, especially this table. True positive, false positive, true negative, false negative, and what is the difference? Hopefully, if you can use those in your research some degree, so hopefully. And so this is the end of this class, and let's continue our discussion next Tuesday. Have a good weekend.